We're now ready to wrap up our discussion of automatic memory management, and so I just want to make a few high-level points here. First of all, there's no question that automatic memory management is a great thing. It prevents very serious storage bugs, some of the most difficult bugs in programming. And when you're writing in a garbage collected language, you really have just a whole class of things you don't have to worry about. And so it is certainly a more productive way to program. So if your program is really a good fit for automatic memory management, then you'd be crazy not to use a system that provided that kind of support. Now, the disadvantage of automatic memory management is that it reduces programmer control. So you don't have control anymore over the layout of data in memory, and you don't have control over when the memory is deallocated. So you neither have control over where the data is in memory, and you have only a very limited amount of control over how much memory your program is using. Okay? And so if these two things don't matter, if your application is not extremely data intensive, where the precise layout of data in memory and how much data is residing in memory is important, then garbage collection will likely work very well. But there are applications, particularly high-end data processing and scientific applications, which use a lot of data and need to make very, very efficient use of the memory, where garbage collection actually becomes too inefficient to do a good job, and people in those domains still use manual memory management. But there are some other issues. So in real-time applications, the pauses can be problematic. So if you have a program that needs to meet guaranteed deadlines, many embedded systems that are interacting with the outside world, say controlling dangerous machinery and things like that, they have to have response times that are guaranteed to make sure that nothing terrible happens. And introducing a automatic memory management system that might pause for arbitrary amounts of time, makes that a very problematic thing to guarantee. So you don't always see garbage collection used in real-time applications, although there has been a lot of progress in the last several years on real-time garbage collectors. Another issue that every programmer who uses automatic memory management probably will have to face is the problem of memory leaks. So while automatic memory management prevents you from corrupting your memory, it really doesn't prevent you from hanging on to too much data and possibly affecting the performance of your program dramatically. So memory leaks are possible in garbage collected languages, and I would say they're even likely. I'd say that the fact that you're not as aware or not as forced to be as aware of how the memory is being used makes it easier to have memory leaks. And the kind of memory leak that you will have in, say, a Java program is that you'll have some variable, say x, that points to some data structure, and this data structure is gigantic. Okay, so let's say that this is the abstract syntax tree in a compiler. All right. Now there may come a point in the computation where you don't need the abstract syntax tree anymore. So let's say that we have converted to an intermediate language and from the abstract syntax tree, and now all of our processing for the rest of the compilation is going to be on the intermediate language representation and generating code from that. And we never go back and look at the abstract syntax tree again. Well, the garbage collector doesn't know that you're not going to use the abstract syntax tree again in the future. And if you have a variable that's pointing to this gigantic data structure, even if you're not using it, it's going to hang around and is going to be using up memory. And so the right thing to do is when you reach a point in the program where you're not going to use this data structure anymore is to assign x the null value. You want to assign x to null at that point, and essentially dropping this pointer to the data structure. And now the garbage collector, whatever form it is, mark and sweep, stop and copy, reference counting, will be able to see that this is no longer reachable and will collect that big structure. And this is very, very common in production Java programs to have these kinds of memory leaks where you just have pointers that you forgot about to data that you're no longer going to use. So as I hope I've conveyed in the last few lectures, garbage collection is a very important technique. Every programmer should be aware of its benefits and costs, and it's also a very interesting aspect of programming language implementation. There are much more advanced garbage collection algorithms than we've discussed in these lectures, and the primary dimensions along which people have thought about improving garbage collection is making garbage collection concurrent. And that means allowing the program to continue to run while the collection is happening. So the collector is working in the background actively while the program is running. Another thing that's very common actually in production collectors is to have what's called a generational collector. And the basic idea here is that we don't want to keep going over and looking at objects that are very long-lived on every collection. So collections happen very frequently, and there will be some objects that just live for a very long time, the big data structures that hang around for most of the program. And once we've seen them in a couple of collections, we probably can assume that they're going to be around for a few more collections. And so in a generational collection, in a generational collector, older objects that have been around for a while, are put in a separate area and they're collected less frequently. And this just allows the collector to focus on the objects that are most likely to be garbage, which are the recently allocated objects. We already talked a little bit about real time. So there are collectors that try to bound the length of the maximum pause, the maximum interruption to the program. And finally, parallel collectors. So systems where there's actually several garbage collectors running at the same time and somehow coordinating their actions.